So in this demo, what we're going to do is we're going to get the ball to move around the screen and collide and bounce off of all the walls. Something that's going to be absolutely necessary for a lot of games, especially if you're making a Pong type game. So we have our ball, we have our 4 rectangles which represent top, bottom, left, and right, which we see right here. Now if you look at how I've defined them, it's kind of ugly what I've done. I've used a lot of constants and got rid of all the magic numbers. Basically, I've used these constants so I can modify these things. So if I draw this, if I draw it on the screen right now, you see that it's very very structured. And I've set the top and the bottom to have half transparency just to show you that the left and the right do not overlap in any way, shape, or form. So basically what I've done is I've said create a 50 pixel gap at the top and the bottom, make each wall 30 pixels wide, and make the ball 20 pixels wide. Now just by changing a number, if I change this 100 to that 50 to 150, you can see that we get completely different results. Everything is kind of shifted up and down. That gap is now 150 at both the top and the bottom. So we can achieve pretty different results just by changing these numbers. And that's why I used all the variables and constants down here as opposed to magic numbers. I can customize it. And just how did I get these numbers? I just pulled out a piece of paper and I calculated it by hand. Made sure that everything worked out appropriately. The ball, on the other hand, is located at the dead center of the screen. And now that being said, it's the top left corner of the ball that's located dead center of the screen. If I wanted it to actually be the center of the ball, I would have to adjust by the width and height, half the width and half the height of the ball from where it's currently located. But that's not really my focus here, so it's not important. So how do we get the ball moving? So what you need to realize is that that ball can move in both the X and the Y direction. So what we're going to do is we're going to create 2 variables to represent both both of those directions. So let's say int X direction, we're going to set that equal to a 1, and int Y direction, and set that equal to a 1 as well. We're also going to have a speed. So let's say int ball speed. Let's set that equal to, I don't know, 3 pixels. So that means every update it's going to move 3 pixels. Now, in which direction? Well, that's what these are for. So if X direction is positive, that means it's going to move 3 pixels to the right. If X direction is negative, that means it's going to move 3 pixels to the left. Similar for Y. If Y is positive, it's going to move 3 pixels down. If Y is negative, it's going to move 3 pixels up. Well, how do we actually calculate that? Well, basically we just need to add to the current location of the ball. And that's all there is to it. So down here, we're just going to say, alright, ball.x is equal to ball.x, so we're adding to itself, plus our speed, ball speed. Now, if we just did this, it would always move to the right. So we want to multiply that by the X direction. Now think about that. Why are we multiplying? Because if X direction is a 1, it's going to multiply by 1, basically do nothing. However, if X direction is a negative 1, that ball speed automatically becomes a negative value, which means it'll move to the left. Similarly speaking, we want to do the exact same thing for the Y value. So ball.y is equal to ball.y plus ball speed times Y direction. Now if we run our program right now, we'll see it move down and to the right, since both of them are positive. And oh, you missed it, sorry about that. You can kind of move it off there. Sorry, my screen's too big, so it's just kind of starting halfway off the screen for you guys. Let's slow it down so it's a little bit easier to see. So let's move it 1 pixel per update. And try that again. And you can see it's moving down on a perfect 45-degree angle. So we know how to move it now. Now if I just change this Y direction, let's say that to a negative to start with, and we should move up now. And we do. So you can see that this can produce pretty different results based on what we want to do. If you wanted to move at different angles other than 45, then these numbers would just have to be different. So for example, if my X direction had a value of 2, that means that it's going to move over to the right 2 pixels for every 1 pixel it moves in the y direction. So we get a much more gradual slope, as I'll show you here. I'm going to change this to a negative though, so it moves to the left, just so you can see it right off the bat. You can see it move at a much shallower angle. If we change this to, let's say, a 5, it's even more shallow of an angle, and then it's moving faster as well. Let's put this back to a 1 for now. And now we need to make sure or check for collisions with the walls. So let's do it one wall at a time, just for testing purposes. So basically, if we collide with the top or the bottom wall, we need to flip the current y direction. Okay. Now we want to check that after we've moved. Okay. So basically, what I'm going to say is if ball dot y. Actually, sorry, that's not what we need. We need to say if box collision, that subprogram we created before, of the ball and the top rectangle is true, or similarly speaking, if it's colliding with the bottom, we need to do the exact same work. We just need to flip the current y direction. So we just need to say y direction. Well, how do we flip a 1 to a -1 or a -1 to a +1? All we have to do is multiply it by -1. So 1 times -1 gives us -1. -1 times -1 gives us 1. So it very easily just flips it. Y direction multiplied by -1. And that will actually flip it if we hit the top or the bottom wall. So let's give it a go. When we see it gets closer, and boom. Now of course we haven't checked it for the other one yet. So now we need to do the exact same thing for the left and right wall. But this time, instead of changing the y direction, we're going to change the x direction. So x direction is equal to x direction times -1. So we're checking the left wall and the right wall. Now let's bring it back. It's going to collide, good, and it should collide here and go back the other way. So now we have a ball that bounces around our screen in a nice 45-degree angle. It never overlaps it in any way, shape, or form. Everything is perfect. Boom, boom, even in the corners. So that's our box-to-box collision detection with bouncing off the walls. You can start modifying this and doing some pretty interesting things pretty quickly, depending on what you want to achieve.